So I'll record on my computer. Okay, I want to welcome everybody to the Renewable Energy Working Group's February webinar. We're pleased to have Rhett Good from West Incorporated here today. Rhett is a certified wildlife biologist and senior ecologist based in West's Bloomington, Indiana office, where he manages wildlife research and monitoring studies and assists clients with ecological issues. Rhett holds a Bachelor's of Science in Biology from Ball State University and a Master of Science in Zoology from the University of Wyoming. Rhett has over 24 years of experience completing large and small conservation planning and monitoring projects across the U.S. Rhett currently serves as Senior Advisor to West's Bat Practice Group and Detection Dog program. So I'm pleased to hand the floor over to Rhett. I believe he may have a co-presenter at times with Andrew. And I would encourage everybody to use the chat box. If you've got questions you want to ask, we may ask those at the end, but it's a good place if something comes up during the presentation to go ahead and get it into the chat box. And then of course you've got the reactions button down there. If you want to give him a thumbs up on any particular points through the way, I welcome you guys to do that as well. So Rhett, I'm going to hand it over to you.
Okay, thank you, Susan. Yeah, and welcome everyone. I'm looking forward to talking about some research we completed today. With me is Andrew Tredenik. He's a senior statistician with West, and we'll be reviewing some of our results and answer any questions you guys have. So the purpose of this research project we'll be talking about was we were trying to determine if combining curtailment and acoustic deterrents could result in further reductions in bat mortality at wind farms. This research was completed at two adjacent facilities located in Northeast Illinois, known as Pilot Hill and Kelly Creek. Both facilities have roughly a generating capacity of around 200 megawatts. Pilot Hill has 103 turbines. They're roughly, I believe, 1.8 megawatt generating capacity. And Kelly Creek, which is the facility to the west in orange, has 92 turbines of similar size. A little bit of background, both of these projects are located in areas that are dominated by row crop and corn and soybeans. There's really no significant forested areas within 6 to 12 miles of these projects. There was originally, original reason for some of the initial monitoring at the site was to determine, is the project having any impact on any listed species? However, despite 4 years of relatively intense monitoring, no Indiana or northern long-eared bats or any myotis carcasses were found, which is good news. However, the tree bat mortality on site was unexpectedly high, which prompted some additional research into methods that could be used to reduce bat mortality. And there's a couple of methods that are typically used to reduce bat mortality. One that I'm guessing most of you on the call are familiar with is known as curtailment. And when we refer to curtailment, it basically means reducing the RPMs below a specified wind speed so that the turbines basically aren't spinning at a speed that could be lethal to a bat. And it's a well-documented method used to reduce bat mortality at wind energy facilities across the US and Canada. I believe 17 plus studies have been shown that it works. And many facilities use what's called blanket curtailment. Basically, anytime the wind is below X speed, those turbine blades are feathered so that they're not spinning at lethal speeds. However, while this practice does result in bat mortality reductions, it also results in significant loss of clean energy. Another method that has been used at some facilities to reduce bat mortality are acoustic bat deterrents. And acoustic bat deterrents, the basic premise behind them is you basically put out a sound that overlaps with the echolocation frequencies of bats. You make that airspace uncomfortable enough or you scare them away so that they don't interact with the turbine blades, and you reduce the bat mortality. So, acoustic deterrents are not cheap. They're expensive to install. And so, and there have been previous studies that had looked at, what are the effectiveness alone of acoustic deterrents for reducing bat mortality. At this project, we decided we wanted to try and answer a different question. And that is, if we combine acoustic deterrents with blanket curtailment below wind speeds of 5.0 meters per second, which is a really standard measured across the US and Canada to reduce bat mortality. Well, does this result in additional reductions in bat mortality? Can we combine these two and maybe eliminate or significantly reduce mortality? And that was the goal of this study. So this was a paired design with these two adjacent wind facilities. So at the Pilot Hill wind facility, which is shown on the east side of this map or the right side, the acoustic deterrent was combined with curtailment at 5.0 meters per second at 15 turbines, and then mortality measured at those 15 turbines and compared to a control group, which is another group of turbines that operated and manufactured cut-in speed, as they were designed to operate out of the box. And those were fixed throughout the study. This study was completed during the late summer and fall, which is the period when most bat mortality occurs, from August 1 through mid-October. At the adjacent facility, there was a study going on at the same time known as Kelly Creek, in which the effectiveness of curtailment at 5.0 meters per second at 15 turbines was compared to, again, 15 turbines that operate at manufacturer cut-in speed straight out of the box. One other thing I should note, and so these two facilities have almost the exact same landscape. They're both dominated by tilled ag. There's really no features here that would distinguish the two facilities. So they're basically, I think from a biological perspective, one big wind farm. So the acoustic deterrents tested at this site are manufactured by NRGS, and there was a little bit of a unique design here. So based on some past research, what past research had shown was, although bats approach turbines oftentimes from behind the turbine blades, past research had blasted high frequency sound, behind the turbine in that leeward side of the turbine blade lake. But what had been found was that was not as effective as some wanted it to be. So at this study, NRG turned the deterrents around so that high frequency sound basically blasted toward the turbine blades. So they're mounted on the nacelle and blasting toward the turbines to better cover the rotor-cept area. One unique aspect of this study was there were also additional deterrents mounted on the rotor, on the actual tower, I should say, to cover the lower portion of the rotor-cept area. And that's what you can see here in this figure on the right. So the goal was to try and increase the area in which high frequency sound would envelope the rotor-cept area. Now, something you should know about high frequency sound is, and I'm no physicist, but basically has this attenuation problem in which, the sounds at which bats echolocate, the sound does not travel very far. It quickly dissipates. And so, and that level of dissipation, how far that sound can actually be measured or felt by a bat, really depends on the frequency that's emitted. So the very highest frequencies do not travel as far. Frequencies that are a little bit lower travel farther. So the NRG deterrents at this site were designed to focus sound in roughly 20 to 50 kilohertz range, which overlaps the bat call frequencies of most of the bats that would occur at this site. But as you can see from this map, this is a modeled map, a figure that models how far high frequency sound would travel relative to a 55-meter blade length. You can see, basically this line on the far right would represent the echolocation frequencies of probably, the lower frequency bats that would occur on site, such as a hoary bat or a silver-haired bat. Or a big brown bat in that lower frequency range. So you can see that would cover a greater portion of the potential rotor-receptor area relative to the higher frequency end here on the left, which would generally overlap for species on this site, such as eastern red bat. So we're not getting a complete coverage of the rotor-receptor area with the acoustic deterrent, but it does depend on the frequency. So just talk briefly about the field methods. Field technicians trained in standard carcass searching methods completed the searches. There was a few study differences that are important to note. At the Pilot Hill facility, at both facilities, they're located in tilled ag. So we had to regularly mow the areas to increase the ability of technicians to find carcasses. The 30 turbines at Pilot Hill were cleared out to 80 meters and at Kelly Creek out to 60 meters. And search frequencies varied between daily to twice weekly, depending on the turbine. There were some separate research projects going on at the site. Technicians walked transect spaced at 5-meter intervals, and searcher efficiency and carcass persistence trials were used to estimate bias on the site. How many carcasses were removed before carcass searchers could find them. And we used a modeling approach to estimate the effectiveness of the treatments, and including in this modeling approach were the differences in study effort to try and account for the differences in plot size and search frequencies. We also included covariates, including weather that could also affect bat mortality and activity at the site, to try and separate some of these effects that could have also affected mortality we saw on the project. We did not have the ideal study design. We ideally would have had a separate control group and a separate group with just the acoustic deterrent. But as I said before, these things are not cheap. They're expensive to install. And so, but we were still interested. We felt like we had an opportunity to estimate what was the potential additional effectiveness of adding the deterrent to curtailment, because we had this adjacent study going on and basically the same biological wind farm from a bat perspective. And so we did estimate what were the additional reductions that could be realized by adding the deterrent on top of curtailment, under the assumption that the reductions we saw at 5.0 meters per second at Kelly Creek at the adjacent facility would also have applied to Pilot Hill. And as I described before, we felt like that was a reasonable assumption. Overall, this is a figure here describing the number of carcasses found. I think I described earlier, no myotis were found at the site. Most of the fatalities were of hoary bats, silver-haired bats, and eastern red bats, and big brown bats. Some interesting results were observed that I'll describe a bit later, but these are the raw results between control and treatment groups between the two facilities. One thing to note here, big brown bats were recorded at one facility, Pilot Hill, but not Kelly Creek. Eastern red, hoary, and silver-haired bats were recorded at both facilities. So we estimated the reductions separately for the two facilities, and these are the figures you see here. And so when we combine all bats, what was the reduction for all bats at the site? At Pilot Hill, we estimated there was a roughly 67% reduction in mortality when you combine curtailment and deterrents, compared to the Kelly Creek estimate of when you only use curtailment, we recorded a 42% reduction in bat mortality. So this provided evidence that there was some additional benefit of adding a curtailment on top of the deterrent. However, when we start looking at this between species, there were some pretty big differences. And so eastern red bat, there was some evidence that adding the deterrent on top of curtailment provided additional benefit. However, the estimated reductions, the confidence intervals did overlap quite a bit. For the hoary bat, it was interesting. Despite some previous studies that showed acoustic deterrents being effective for hoary bats, we did not observe a difference between curtailment only versus curtailment plus deterrent as far as the reductions go. And I think this is actually really good news for the hoary bat. I think it shows that curtailment works as well as deterrents work. However, it appears as if you don't get a lot of additional benefit, at least at the facility we study, when you add curtailment on top of the deterrent for the hoary bat. For the silver-haired bats, we saw large differences. So curtailment had very limited to no effect on reducing silver-haired bat mortality at the site. We estimate a 14% reduction and confidence intervals that really basically overlap zero. And this was interesting because we did have some ongoing research using acoustics mounted on the nacelles and at the Pilot Hill facility during this study, and found that we observed silver-haired bats echolocating at the nacelle in some very high wind speeds. And we have noticed at some other facilities that, curtailment has an uneven effect, it appears, on silver-haired. It appears to work at some facilities and not others. However, at this facility, when we added curtailment and the deterrent, we saw a major reduction in mortality. We estimate a 71% reduction in silver-haired bat mortality at the site. So the final species that we looked at was big brown bat. I mentioned that we did not find any at Kelly Creek, so we really couldn't estimate what is the potential additional benefit. However, at Pilot Hill, we observed a 94% decrease in mortality between treatment and control turbines when you add the curtailment plus deterrent. So how do these results compare to other studies that have looked at deterrents? And the reductions we observed at Pilot Hill were higher than the three studies in the published literature that have looked at the acoustic deterrents on their own compared to control turbines. So this does provide additional evidence to suggest there is some additional benefit by adding these two on top of each other. However, there are some really important between study differences that should be noted. In particular, blade lengths. All these have pretty similar blade lengths. However, we're looking at some different types of deterrents. The NRG system tested at the Texas facility was basically the same system we tested, except they did not have deterrents mounted on the towers. The California Ridge study was a different type of deterrent used by GE, a similar concept, but a different technology and different orientation of the sound. And Locust Ridge study was the very first study ever completed on acoustic deterrents, led by Ed Arnett. And that was a very early technology. So we did take this opportunity, again, under the assumption that, the reductions we saw in curtailment at Kelly Creek, were the same as if we had studied that at Pilot Hill. And then tried to estimate what is the additional benefit if you add deterrence on top of curtailment. And so again, if we put our blinders on to the between species difference in the all bat number, it would appear as if we get a 42% additional benefit. That's pretty large, right? That's a good additional benefit. However, again, it really varied between the species. So, after accounting for those other variables that could affect bat mortality, such as, temperature, wind speed, all those covariates, we did estimate there was a potential additional benefit of 31% for eastern reds, but again, that confidence interval overlapped 0. So not a very strong effect, but suggests there was additional benefit at this facility for eastern reds. For hoary bats, again, we estimated there was really no evidence of a strong benefit for adding the two on top of each other. And those confidence intervals really overlap 0. For silver-haired bats, though, we estimated there was a 66% additional reduction in mortality when adding that deterrent on top of the curtailment. So really that all bat number is being driven largely by the additional benefit for silver-hairs here. So what are the management implications for our study? I think there's a tendency for for a lot of us to think of the bat problem and estimating bat mortality and measures for reducing bat mortality. We tend to lump all these bats together, treat them as one species, and focus on this all bat number. However, it's our results suggest it's becoming clear that we really need to look at each one of these species different. They have very different ecologies. They really appear to respond differently to curtailment and deterrence. And so, if you have a facility that has a target reduction, it's really important to consider what species, what the relative percent composition of each bat species is at the site in order to generate the most cost-effective method for reducing bat mortality. I talked a little bit about silver-haired bats. It was very interesting to see how little benefit we observed at silver-haired bats at this site. Now, there have been, I believe, 3 curtailment studies that have shown a benefit for curtailment. But I believe there's also a couple of others that have shown limited benefit. And so, silver-haired bats showed remarkably little reduction with curtailment, but adding the deterrent really significantly reduced silver-haired bat mortality at the site. And it's significant to note that species is in the lower end of the echolocation frequency range. And again, remember, that's the lower the frequency of the sound, the farther that travels. So the more that rotoreceptor area is being covered. The eastern red bat was interesting. So, I mentioned, there was some evidence of additional benefit for adding the eastern red bats. It wasn't strong, but some past studies have actually shown increased red bat mortality when you're just looking at the deterrent. And I think this is significant. And I think there's a couple of explanations for that. For eastern red bats, remember, they echolocate. They have a wider range, but they often echolocate in that higher range. That sound doesn't travel as far. And some past research has suggested that, they might be getting pushed, away from the nacelle, but that sound isn't traveling far enough. So they're getting pushed maybe to a riskier portion of the turbine at the ends of those turbine blades that are spinning faster. For this study, it was unique in that there were additional deterrents mounted on the actual tower compared to other studies of NRG deterrent. And that appeared to potentially be a reason why we saw better results here for eastern reds. Again, there's additional studies are needed to further investigate this, but it might explain why we we did see some additional benefit here for eastern reds. The hoary bat results were a little surprising. Another study completed by Sarah Weaver in Texas estimated that energy deterrents there reduced hoary bat mortality by 78%. Here we really didn't see much difference between curtailment plus deterrent versus just curtailment for hoary bats. But again, I don't think that means the deterrent doesn't work for hoary bats. It potentially suggests you don't get a lot of additional benefit by adding the two, but those prior studies have shown deterrents work for hoary bats suggest that either method could potentially work for hoary bats, which is good news, I believe, for hoary bats, and provides more options for reducing bat mortality. Now, I think there's always a couple caveats that you have to keep in mind. I know it's, anytime we can get additional benefit by adding additional technologies is tempting. Oh, why aren't we doing this at every facility? I think it's important to remember that there were some unique aspects about Pilot Hill that's, may not be applicable to other facilities. So such as turbine warranties. I believe turbine warranties at many facilities would prevent mounting of deterrents on the actual towers. So the approach we used at Pilot Hill may not even be feasible or allowable at other facilities. The other consideration is mounting deterrents on the towers significantly increases the expenses. You have to have an additional lift, you have to have additional time to mount them, and you have to take them down. The deterrents on the tower, they did not damage the tower at all, but you have to take them down before winter starts to prevent icing, and that would potentially cause damage if you had an icing event. So all that's to say, it worked here, but it could be prohibitively expensive at other facilities. Like many research, you often generate more questions than you do answers. And so at this facility and others, there's a real question of, will this deterrent work as turbine blades and turbines grow larger? So all the research to date has been really conducted at facilities that have turbine blades 55 meters or smaller. Many of the new 3.0, 4.0 megawatt turbines, I'm seeing blade lengths of 70, 75 meters in length. Will we see the similar reductions for deterrents with those large turbines? And again, remembering that attenuation problem that deterrents have, that's a real unknown. I mean, I think some results suggest that we're probably not going to see the same level of reductions with those larger turbines. But additional studies need to be completed to see what the benefits might be at those larger turbines. Again, in an ideal scenario, we would have had a deterrent only treatment here. We didn't. I do think it's worthwhile to have additional studies in the region looking at acoustic deterrents only to isolate that effectiveness. So what does the deterrent alone get us? And finally, I think, what's really missing here is, all these fixes for bat mortality are not cheap. Curtailment is not cheap. It results in significant losses in renewable energy. Depending on the site, those revenue losses may be much larger than some of the previous literature that you've read suggests. Deterrents aren't cheap. There's significant equipment costs. They have limited warranties. You're probably looking at potentially replacing the units a couple times or more during the lifetime of facility. And so none of these things are small dollar amounts. And so what we really need is additional research on tree bat population sizes and trends. So we know these levels of mortality we're seeing are, higher than we expect and are concerned, but we really lack any good information on tree bat population sizes or trends. To know, is the level of mortality sustainable? Do we need an all of the above approach for every facility? Or, can these levels of reductions, or, basically we need to know what the levels of populations are so we can actually set good conservation targets. And then we can really better design effective measures and targeted measures for reducing mortality. And with that, I just want to acknowledge, there's a lot of people who made the study happen. It would have never happened without EDF and Mike Azeka's, really forward thinking on how to test different ways to reduce bat mortality. And a lot of other folks at West have really led a lot of the work on this project. I'm just here presenting results today. So with that, we will open it up for questions.
Thank you, Rhett. We really appreciate you taking the time to present to us. We did get one question in the chat box that I can see. Bob asked, and I welcome everybody. There are so few of us on this call that I welcome everybody to go ahead and just unmute and ask your questions, or you can go down to the reactions button at the bottom of your screen, click it, and then there's a raise hand option too. So however you'd like to do that. Bob Stratton, why don't I go ahead and just turn it over to Bob and he can ask his question directly. Bob?
Sure, I can do that. Can you hear me yet?
Yes.
Yes.
Great, super, and thanks for the invitation to this webinar, Susan, and Rhett. Thanks for the presentation. I work in Maine for Maine Fish and Wildlife, and these are studies and issues that we debate a lot in the facilities that we review. I'm the environmental program manager for IFNW. And so our concerns are largely with the 8 species we have in Maine. Like many other states, we have 2 endangered, 1 threatened, and 5 special concern or rare species. And myotis are our largest concern. So my questions come mainly myotis related. And as you mentioned when you started out, the high frequency calls like we see with myotis species don't travel far. So when you look at putting deterrents, and we tried to do some deterrent testing in Maine, we found our populations were so small that we really couldn't test them. So inevitably, when looking at other technologies other than what's referred to as blanket curtailment, we don't necessarily like that term because we have more of a bell-shaped curve of what we do based on the high mortality season in late summer, but we're using and recommending higher speeds than 5.0 that you used in your study. We're using 6.0 and then increasing in late summer between mid-July and mid-September to 6.5 on some projects, 6.9 on others, and issuing an ITP for those projects. But so some of my questions are how would your study compare with higher wind speeds, such as those 6.0, 6.5, and 6.9? But the bigger question I have is, and our pilot study that we tried to work with was with NRG, trying to figure out how you tackle that problem with extending a signal, a high frequency signal, to cover more of the rotor sweep zone so that you could have a confidence in protection of myotis species. Thoughts on either of those? I like how you try to include more deterrents on the tower, on the nacelle, and how you're directing it, but any further thoughts on what you could do that would give a greater level of confidence that you're covering the rotor sweep zone for higher frequency calls?
Right. Great question. And so, yeah, unfortunately, it's hard to find a site that has high enough myotis mortality anymore to actually field test something like this. And so a couple thoughts there. There is some DOE funded research that I think is wrapping up And so to try to address some of those concerns you just raised. So I believe one of the studies completed by, I think it's Texas State, they are working with NRG to test what is meiotis response to low frequency sound. So I think we've all been approaching this, okay, you got to match the frequency to scare the bat away. Well, maybe not. Maybe, I think the thought is, can you use low frequency sound, which assuming the meiotis can hear that, will they respond to the low frequency sounds? And if they do, then perhaps, this will be as effective for meiotis. We don't know, but that's currently happening. So keep your eyes out for that results of that research.
Okay. We've also been encouraged, more hopeful, I should say, that the work that USGS was doing with essentially painting turbines and blades with UV light might show more progress. I know the first year they had some technical problems with that, but given that that would extend further than acoustic signals, I guess with fingers crossed, if anything like that would go further.
Right. Well, yeah. Yeah, I think we're all very hopeful of that idea because it sure would be simple to implement. I believe Paul Cryan's report just came out on some of his initial testing at NREL, the NREL turbine on that. And at least using the camera work, I don't believe they saw large differences
Right.
at that single turbine. So I will say with the meiotis, I think smart curtailment and really, better understanding when these bats actually die, when they're actually present in the rotor-sept area, are they actually getting killed in the lower or upper portion? I think there's real potential to dial in curtailment of those specific periods of risk with some additional monitoring and better understanding of when these bats actually die, because we're all kind of guessing right now when we find this carcass. We know it died sometime the night before, but did it die at 2 a.m.? Did it die when the winds are at 9 or when they're at 3.5 meters per second? We don't know, unfortunately.
Well, and your site had mowed ag fields. So many of ours are forested or at least regenerating stands as well. That provides difficulty. And when I looked at what was being covered by acoustic monitoring, at least in smart curtailment, I was getting between 3 and maybe 16% of the rotor sweep zone. So it led to be more of a concern if you weren't validating it with canine searches as well in our types of terrain. But I remain open-minded and hopeful. I appreciate your presentation and listening to me ramble for so long. But thanks.
No, good questions.
Do we have other questions? I've got one, Rhett. I don't do a lot of work in the wind arena, so I haven't kept up on a lot of this. But one thing that I've always been passionate about, I guess you could say, is the need to really involve the industry professionals in the decision making and the conversation. A lot of times we've got the wildlife folks kind of preaching to the choir, so to speak. And I'm wondering if you've got a good sense of where the industry stands as a whole on trying these new deterrents, and if there's an ability to really incorporate financial capital from the industry that they might want to invest in trying to get these deterrents, or at least the studies done on a larger geographic basis, so that we're not just dealing with these small sample sizes and stuff. Where are you guys with that?
I would say that the vast majority of the research completed to date has been industry funded. And so, I think, so I think the industry is really would like to see a tool such as deterrents be more, be established, right? There's no loss in renewable energy. So, I think that you're seeing that, this Pilot Hill study is one outcome of that. You see Duke Energy funding research and implementing, deterrents at a facility in Texas. But, before, there's just so many questions before someone would invest and install this as on every facility, because the costs are not small enough. So how do you spur more research? And, I think it's, I think you're seeing it. I think you're seeing it by DOE, and you see it with private industry.
And I know we've got some folks on the line that are in Texas, I believe. I was wondering if those folks had any, you had mentioned a Texas study, I think, Rhett. So I was curious to know if our Texas folks have any input about what's going on in Texas, and whether that can tie back to anything that Rhett has talked about today. Jessica or Karen, do you have any input?
This is Jessica. I don't really see that much wind in the area that I review projects, so I don't really have much to add. I don't know if Karen has anything, but yep, sorry, not much to add.
So for me, it's the same situation. I review mostly East Texas, and we're just slowly getting wind projects in my area of review. And so I'm still trying to learn the impacts. In Texas, there's not a whole lot of regulatory authority. So at the state level, we don't see a lot of data that comes in unless we are involved in the research project. And I think we have a staff member who's been involved on one of the South Texas wind sites for that acoustic deterrent. But yeah, I don't have anything else to add.
Every time I try to unmute, I get pop-ups in front of my unmute button. So it's kind of hard to unmute when you're the host. Does anybody else have any questions today for Rhett? Or Andrew, do you have anything to add to what Rhett talked about?
I do not. No. I mean, he touched on the main results. Anything else with the statistical modeling is just sort of complexities behind the scenes so that we could isolate these kind of effects that Rhett talked about.
Yeah, I was thinking through the statistics as he was talking and thinking, boy, that had to have been a challenge to try to tease out what was actually a real effect versus something that was not. So, okay, well, again, I want to thank Rhett for providing this information. It was exciting research to me. I'm really thrilled I want to go back and re-listen to some of this at the beginning. But for everybody else, the Renewable Energy Working Group is having monthly webinar series. We try to shoot for the last full week of each month. Next month, we're going to have Michael Fishman talking about solar ecosystem enhancement planning. That is scheduled for March 24th. I'm not sure what day of the week that is, but March 24th at 3 p.m. Eastern time. So March 24th, 3 p.m. Eastern time. We are announcing the webinar series in the eWildlifer. They're open to all TWS membership. This is a way to increase, membership interaction with renewable energy issues. And so I welcome you guys to invite your colleagues. You should be able to get we'll be announcing the link and stuff as the date gets a little closer. So anyhow, thank you all for attending. And if you have any questions or anything, I'm going to put my email in the chat box. There you go. So feel free to reach out to me. Make sure I'm whitelisted. That email address sometimes goes into people's junk mail. But anyhow, we hope we see you guys in a month on March 24th. So thank you all for attending.
Thank you, Susan.
Thanks, Rhett. Bye.